Hello, my name is Daniel Igamodu. I'm thrilled to welcome you to a course that has the power to transform your life. Have you ever dreamt of launching your online business, setting up your own computer business center, or simply wanting to learn how to use a computer for work, school, or fun? From the comfort of your home. If that is your case, you do not need to look any further. The idea of creating this course came to me when a few individuals approached me for money to go and learn how to use a computer at a local computer school. There is a saying that necessity is the mother of invention. Since I have a computer background, I created this course to cater to those in this category. If you have never turned on a computer before, or have very limited computer knowledge, this course is for new beginners and individuals with little computer skills. It will take you from zero knowledge, meaning you know nothing about computers at all, to proficiency in operating one with ease. In this course, we'll guide you through unboxing a new computer, setting it up, connecting to the internet, and browsing the web. In a world where opportunities flow through digital currents, computer literacy is not just an advantage, it's an absolute necessity. We stand at the crossroads of a digital revolution, where artificial intelligence and computer mastery shape the course of our future. Embrace this journey with us and unlock the potential that comes with proficiency in the digital age. Whether you're an aspiring entrepreneur, a job seeker, a student, or someone simply looking to enhance your everyday life, this course is tailor-made for you. Consider this. The global shift towards remote work, the rise of the gig economy, and the relentless march of technology have all converged to create a landscape where computer skills are the keys to unlocking a world of possibilities and opportunities. Picture this. Without a strong foundation in computer literacy, you risk being left behind and relegated to the sidelines while others seize opportunities and amass wealth. It's a daunting prospect, but fear not. This course is your bridge to the digital future, your opportunity to level the playing field, and your ticket to the world of limitless possibilities. Over the coming weeks, we will dive deep into the Windows 11 operating system, revealing its intricacies and mastering its tools. But beyond that, we will empower you with the confidence and competence to thrive in the digital age. We believe that everyone can become a proficient computer user regardless of their starting point. So, if you're ready to take control of your digital destiny, open the doors to new opportunities and possibilities, and embrace a future filled with technological wonder, then you're in the right place. Let's embark on this journey together, where we will demystify the digital, conquer the computer, and empower you to flourish in the information age. Welcome to How to Use a Computer. Get ready to transform your world one byte at a time. Welcome to How to Use a Computer, your comprehensive guide to mastering computer literacy using Windows 11. Before we dive into the practical aspects of using a computer, let's take a brief journey through the fascinating history of computers and the invention of the Windows operating system. A brief history of computers. The history of computers dates back to the early 19th century. It all began with mechanical devices designed to perform simple calculations. One of the first such devices was the difference engine, conceptualized by Charles Babbage in the 1820s. Charles Babbage, often referred to as the father of the computer, envisioned a machine that could automate mathematical calculations. Although his difference engine was never completed during his lifetime, it laid the groundwork for future developments in computing. In the mid-20th century, electronic computers began to take shape. The ENIAC, developed in 1945, was one of the first electronic general-purpose computers. It was soon followed by the UNIVAC, which became the first commercially available computer in 1951. The 1970s marked the advent of personal computers. Pioneering companies like Apple and IBM introduced the Apple I and the IBM PC, bringing computing power into homes and small businesses for the first time. The birth of the Windows operating system. In the early 1980s, a young company called Microsoft, founded by Bill Gates and Paul Allen, set out to revolutionize personal computing with a new kind of software, the operating system. In 1985, Microsoft released Windows 1.0, a graphical extension for MS-DOS that introduced a more user-friendly interface. This was the beginning of what would become the world's most widely used operating system. Windows 3.1, released in 1992, gained widespread popularity with its improved graphics and multitasking capabilities. In 1995, Windows 95 brought significant advancements, including the Start menu and taskbar, which became fundamental elements of the Windows experience. The success continued with Windows XP in 2001, known for its stability and user-friendly interface. Over the years, Windows has continued to evolve, adapting to the changing needs of users. Windows 7 in 2009 improved performance and usability, while Windows 8 introduced a touch-friendly interface in 2012. Windows 10, released in 2015, unified the experience across devices. Today, Windows 11 represents the latest in Microsoft's commitment to innovation, featuring a sleek design, enhanced security, and new productivity tools. With this historical context in mind, you are now ready to embark on your journey to becoming proficient in using a computer. Our course will guide you step by step through the basics of computer hardware, software, and the Windows 11 operating system. Whether you're a complete beginner or looking to refresh your skills, this course is designed to take you from zero to hero in no time. Computers and their wide range of applications. Communication. Computers have revolutionized the way we communicate. They offer various applications that allow us to connect and collaborate with others easily. Email enables quick and efficient communication, allowing users to send and receive messages, documents, and files instantaneously. Social media. Platforms like Facebook, Twitter, and Instagram connect people globally, allowing them to share updates, photos, and videos. Video conferencing. Tools like Zoom, Microsoft Teams, and Skype facilitate real-time video meetings, enabling remote work, virtual meetings, and online collaboration. Productivity. Computers enhance productivity by providing powerful tools that help users accomplish work more efficiently. Word processing. Software like Microsoft. Word and Google Docs allow users to create, edit, and format documents easily. Spreadsheets. Programs like Microsoft Excel and Google Sheets help users organize, analyze, and visualize data through tables, charts, and graphs. Presentation software. Tools like Microsoft PowerPoint and Google Slides enable users to create engaging presentations for meetings, lectures, and conferences. Entertainment. Computers offer a wide array of entertainment options, making them an essential part of leisure activities. Gaming. From simple online games to complex high-definition video games, computers provide an immersive gaming experience. Streaming videos. Services like Netflix, YouTube, and Hulu allow users to watch movies, TV shows, and other video content on demand. Listening to music. Platforms like Spotify, Apple Music, and Pandora enable users to stream music, create playlists, and discover new artists. Education. Computers play a crucial role in education by providing tools and resources that enhance the learning experience. Online learning. Platforms like Coursera, Khan Academy, and Udemy offer courses on a wide range of subjects, accessible to learners anywhere in the world. Research. Access to vast amounts of information through digital libraries, databases, and search engines helps students and researchers find relevant information quickly. Simulations. Educational software and simulations help students understand complex concepts by providing interactive and visual learning experiences. Business. In the business world, computers drive efficiency and growth by supporting various critical functions. Data analysis. Tools like Microsoft, Power BI, and Tableau help businesses analyze large data sets, identify trends, and make data-driven decisions. Inventory management. Software solutions manage stock levels, track shipments, and ensure that businesses maintain optimal inventory levels. Customer relationship management, CRM. Platforms like Salesforce and HubSpot help businesses manage customer interactions, track sales, and improve customer service. In summary, computers are integral to modern life, facilitating a wide range of activities in personal, educational, and professional contexts. Understanding their key components, functions, and applications helps us make the most of this powerful technology. Thank you for watching, and stay tuned for more educational content. Input devices, such as keyboards and mice, are essential peripherals that allow users to interact directly with a computer. They provide a means for users to input data, execute commands, and control the computer's operations, playing a crucial role in the overall user experience. Here's an elaboration on their functions and importance. Keyboards 1. Data entry. Keyboards enable users to enter text, numbers, and symbols into the computer. This is vital for tasks ranging from writing documents and emails to coding and data entry. 2. Command execution. Keyboards provide various function keys, control keys, and shortcuts that allow users to execute commands quickly. For example, pressing Ctrl+C copies selected text, while Ctrl+V pastes it. 3. Navigation. Arrow keys, page up-down, and home end keys help users navigate through documents and web pages efficiently. 4. Specialized functions. Some keyboards come with additional keys for multimedia control, internet browsing, and launching specific applications, enhancing productivity and convenience. Mice 1. Pointing and clicking. The mouse is used to point to objects on the screen, select items, and open files or applications with clicks. This pointing mechanism makes it easier to interact with the graphical user interface. 2. Dragging and dropping. Mice allow users to drag objects across the screen and drop them in desired locations, facilitating file management and graphical design tasks. 3. Scrolling. The scroll wheel on a mouse enables users to scroll through documents, web pages, and applications smoothly and quickly. 4. Precision. Mice offer precise control for tasks that require accuracy, such as graphic design, gaming, and detailed editing. Additional input devices. 1. Trackpads. Often found on laptops, trackpads perform similar functions to mice, allowing users to move the cursor, click, and scroll using finger gestures. 2. Touchscreens. These allow direct interaction with the computer by touching the screen. Touchscreens are commonly used in tablets, smartphones, and some laptops and monitors, providing an intuitive and interactive user experience. 3. Stylus pens. Used with touchscreens, stylus pens enable precise input for drawing, writing, and detailed navigation. 4. Voice input. Microphones and voice recognition software allow users to input commands and data using their voice, providing an alternative to typing and clicking. Importance 1. User interaction. Input devices are the primary tools for users to interact with their computers, making them indispensable for day-to-day operations. 2. Efficiency. They enable efficient data entry and command execution, significantly enhancing user productivity. 3. Accessibility. Input devices cater to different user needs and preferences, offering various ways to interact with the computer, ensuring accessibility for a wide range of users. In summary, input devices such as keyboards and mice are fundamental components that bridge the gap between users and computers. They facilitate the input of data and commands, making it possible for users to perform a wide array of tasks efficiently and effectively. Output devices, such as monitors and printers, play a crucial role in the interaction between computers and users by converting processed data into a format that humans can easily understand and use. Here's an elaboration on their functions and significance. Monitors. Visual display. Monitors are the primary output devices for displaying visual information generated by the computer. They show text, images, videos, and graphical interfaces, allowing users to interact with software applications and digital content. Resolution and clarity. Monitors come in various resolutions, from standard definition to high definition, HD, 4K, and beyond. Higher resolution monitors provide clearer, sharper images and text, enhancing the viewing experience. Size and aspect ratio. Monitors are available in different sizes and aspect ratios to suit various needs. Larger monitors or multiple monitor setups can increase productivity by providing more screen real estate. Color accuracy. For tasks requiring precise color representation, such as graphic design, photo editing, and video production, monitors with high color accuracy and wide color gamuts are essential. Touchscreen capability. Some monitors include touchscreen functionality, allowing direct interaction with the display. This feature is particularly useful for kiosks, interactive displays, and certain professional applications. Printers document production. Printers produce physical copies of digital documents, images, and graphics. They are essential for creating hard copies of reports, photographs, flyers, and more. Types of printers. Inkjet printers, suitable for high-quality photo prints and general-purpose printing. They use liquid ink sprayed onto the paper. Laser printers. Known for their speed and efficiency, laser printers use toner and are ideal for high-volume text document printing. All-in-one printers. These multifunctional devices combine printing, scanning, copying, and faxing capabilities, making them versatile tools for home and office use. Printing resolution. Printers are measured by their resolution in dots per inch, DPI. Higher DPI values indicate finer print quality, important for detailed images and professional documents. Printing speed, measured in pages per minute, ppm. The printing speed varies among printers. Faster printers are beneficial in environments where large volumes of documents need to be printed quickly. Other output devices. Speakers and headphones. These audio output devices convert digital audio signals into sound, allowing users to hear music, voice, and other audio outputs from the computer. Projectors. Projectors display visual output onto large screens or surfaces, ideal for presentations, lectures, and entertainment purposes. Plotters. Used primarily for large-scale printing, such as architectural blueprints, engineering plans, and large graphics. Plotters draw continuous lines and are capable of producing large, detailed images. Importance of output devices. User interaction. Output devices provide a way for users to see and hear the results of their interactions with the computer, making the use of digital applications and data comprehensible and practical. Data interpretation. By converting digital data into human-readable formats, output devices allow users to interpret and analyze information effectively. Accessibility. Output devices make computing accessible to a broader audience by providing different ways to receive and perceive information, whether through visual, auditory, or printed mediums. In summary, output devices like monitors and printers are essential components of computer systems, transforming processed data into formats that are accessible and useful to humans. They facilitate a wide range of activities, from everyday computing tasks to specialized professional applications, enhancing the overall functionality and user experience of digital technology. Software, an overview. Software is a collection of programs and instructions that tell the computer how to perform specific tasks. It is divided into two main categories: system software and application software. System software. This includes the operating system, OS, and utility programs that manage and maintain computer resources. Application software. These are programs designed to perform specific tasks for users, such as word processors, web browsers, and games. Operating system, OS. The operating system is the most crucial type of system software. It acts as an intermediary between the computer hardware and the user, providing a stable environment for other software to run. Here's a deeper look into its functions and examples. Functions of an operating system. Resource management, CPU management. The OS allocates CPU time to various tasks through scheduling, ensuring that all processes receive adequate processing time. Memory management. It manages the computer's memory, allocating space for programs and data while optimizing overall system performance. Storage management. The OS controls data, storage and retrieval on hard drives, SSDs, and other storage devices, organizing files in a structured manner. Device management. It manages communication between the computer and its peripheral devices, for example, printers, mice, keyboards, using device drivers to ensure compatibility and proper functioning. User interface. Graphical user interface, GUI. Most modern operating systems provide a GUI, allowing users to interact with the computer through graphical elements like windows, icons, and menus. This makes the system more user-friendly. Command line interface, CLI. Some operating systems offer a CLI for advanced users who prefer typing commands to perform tasks. This can be more efficient for certain tasks and provides greater control over the system. File management. The OS organizes and manages files on storage devices, providing a hierarchical file system structure with directories and subdirectories. It handles file permissions and security, ensuring that users have appropriate access to files and protecting data from unauthorized access. Process management. The OS handles the execution of processes, which are instances of running programs. It manages process creation, execution, and termination. It ensures multitasking by allowing multiple processes to run concurrently and efficiently, using techniques like time sharing and process prioritization. Security and access control. The OS implements security measures to protect the system from threats like malware and unauthorized access. It manages user accounts and permissions, ensuring that users have appropriate access levels to system resources and data. Networking. The OS manages network connections, enabling communication between computers over local networks and the Internet. It provides networking protocols and services, facilitating data exchange and resource sharing across network devices. Examples of operating systems. Windows. Developed by Microsoft, Windows is one of the most widely used operating systems for personal computers. It offers a user-friendly GUI, extensive hardware support, and a vast ecosystem of applications. Popular versions include Windows 10 and Windows 11, which are known for their modern interfaces, robust security features, and integration with Microsoft services. macOS. Developed by Apple, macOS is the operating system for Mac computers. It is known for its sleek design, seamless integration with other Apple products, and strong focus on security and privacy. Recent versions like macOS Big Sur and macOS Monterey offer advanced features such as improved performance, enhanced user experience, and a wide range of built-in applications. Linux. Linux is an open-source operating system that comes in various distributions, distros, like Ubuntu, Fedora, and Debian. It is popular among developers, system administrators, and users who prefer a customizable and flexible OS. Linux is known for its stability, security, and efficiency. It is widely used in servers, supercomputers, and embedded systems, as well as by enthusiasts for personal use. Application software. While the operating system provides the foundation, application software enables users to perform specific tasks. Examples include productivity software, word processors, for example Microsoft Word, spreadsheets, for example Excel, and presentation software, for example PowerPoint. Web browsers, programs like Google Chrome, Mozilla Firefox, and Microsoft Edge that allow users to access and navigate the Internet. Media players, software for playing audio and video files, such as VLC Media Player and Windows Media Player. Games, software designed for entertainment, ranging from simple puzzles to complex simulations and multiplayer online games. Design and development tools, applications for graphic design, for example Adobe Photoshop, software development, for example Visual Studio, and 3D modeling, for example Blender. Conclusion. Software, particularly the operating system, is vital for the functioning of a computer. The OS manages hardware resources, provides a user interface, and offers essential services that allow application software to run efficiently. Together, system and application software enable users to perform a wide range of tasks, making computers versatile and powerful tools for work, entertainment, and communication. Random access memory, RAM, plays a crucial role in a computer's performance and functionality. Temporary storage. RAM is a type of computer memory that is used for short-term data storage. It temporarily holds the data and instructions that the CPU needs to access quickly while performing tasks. Purpose. RAM enables the CPU to read and write data at high speeds, which is essential for running applications and executing commands efficiently. RAM is a volatile memory, which means it requires power to maintain the stored information. When the computer is turned off, all data stored in RAM is lost. This volatility is why data needs to be saved to a permanent storage device, such as a hard drive or SSD, to prevent loss when the system is powered down. How RAM works. Data storage. When you open a program, it is loaded from the hard drive into RAM. This allows the CPU to access the program's instructions and data much faster than if it had to read them directly from the slower hard drive. Multitasking. RAM allows multiple programs to run simultaneously without significant slowdowns. It keeps the necessary data for each program readily accessible for the CPU. Performance impact. The more RAM a computer has, the more data and programs it can handle at once. This is why upgrading RAM often leads to better performance, particularly for tasks like gaming, video editing, and running complex applications. Types of RAM. Dynamic RAM, DRAM, the most common type of RAM used in modern computers. It needs to be refreshed thousands of times per second to retain data. Static RAM, SRAM, faster and more reliable than DRAM, but also more expensive. It is typically used for cache memory and CPUs. RAM specifications. Capacity, measured in gigabytes, GB. Higher capacity means more data can be stored and accessed quickly. Speed, measured in megahertz, MHz. Higher speed means data can be read and written faster. Form factor includes DIMM for desktops and SODIMM for laptops. Understanding the role and functionality of RAM helps to appreciate its importance in the overall performance and efficiency of a computer system. It is a critical component that directly affects how smoothly and quickly your computer can run applications and process data. Computer storage, hard drive, HDD, and solid-state drive, SSD. Storage devices are essential components of a computer, responsible for saving and retrieving digital data and programs. Here's a detailed look at storage and its importance. Permanent storage. Storage devices provide long-term data retention, meaning they hold data permanently, even when the computer is turned off. Purpose. They store the operating system, applications, documents, media files, and other data that users need to access over time. Types of storage devices. Hard disk drive, HDD. Components. HDDs use spinning disks, platters, coated with magnetic material to store data. They have a read-write head that moves across the platters to read or write data. Capacity. HDDs offer large storage capacities at a relatively low cost, typically ranging from hundreds of gigabytes, GB, to several terabytes, TB. Speed. They have slower read and write speeds compared to SSDs because the mechanical parts take time to move. Durability. More susceptible to physical damage due to the moving parts. Solid-state drive, SSD. Components. SSDs use flash memory chips, similar to those in USB drives, to store data. They have no moving parts. Capacity. SSDs are available in capacities similar to HDDs, but they are more expensive per gigabyte. Speed. Significantly faster than HDDs, providing quicker boot times, faster file transfers, and overall improved system performance. Durability. More durable and reliable because there are no moving parts, making them less prone to physical damage. How storage works. Data storage. When you save a file, install a program, or download media, the data is written to the storage device. The operating system manages where and how data is stored. Data retrieval. When you open a file or run a program, the data is read from the storage device and loaded into RAM for quick access by the CPU. File system. The storage device uses a file system such as NTFS for Windows, HFS Plus for macOS, or ext4 for Linux, to organize and manage files and directories. Advantages and disadvantages. Choosing between HDD and SSD. Performance needs. SSDs are preferable for tasks requiring fast data access, such as gaming, video editing, and running the operating system. Budget considerations. HDDs are a cost-effective solution for storing large amounts of data where speed is less critical, such as for backups or media libraries. Hybrid solutions. Some systems use a combination of both, known as hybrid drives or SSHDs, to balance cost and performance. Additionally, many computers use an SSD for the operating system and essential applications and an HDD for storing larger files. Key specifications. Capacity, the amount of data that can be stored, measured in gigabytes, GB, or terabytes, TB. Read-write speed, the rate at which data can be read from or written to the device, often measured in megabytes per second, MBS. Form factor, physical size and shape, such as 2.5-inch or 3.5-inch for HDDs and 2.5-inch or M2 for SSDs. Interface, the connection type such as SATA, common for both HDDs and SSDs, or NVM, a newer, faster interface for SSDs. Summary. In summary, storage devices like HDDs and SSDs are crucial for retaining data permanently. They provide the space needed to store the operating system, applications, and personal files. SSDs offer faster speeds and greater durability, while HDDs provide more storage capacity at a lower cost. Understanding the differences between these storage types helps users make informed decisions based on their specific needs and budget. Types of computers. 1. Personal computers, PCs. Desktops. Purpose, designed for use at a single location, typically on a desk. Components, consists of a monitor, keyboard, mouse, and a central processing unit, CPU tower. Usage, ideal for tasks requiring significant processing power and storage, such as gaming, graphic design, video editing, and general office work. Advantages, generally more powerful and easier to upgrade than laptops. They offer better ergonomics with larger screens and more comfortable keyboards. Laptops. Purpose. Portable computers designed for use on the go. Components. Integrated monitor, keyboard, touchpad, and battery within a single unit. Usage. Suitable for a wide range of activities, from browsing the web and streaming videos to office tasks and light gaming. Advantages. Portability and convenience, allowing users to work from virtually anywhere. 2. Workstations. Purpose. High-performance PCs designed for technical or scientific applications. Components. Similar to desktops but with more powerful processors, memory, and graphics capabilities. Usage. Used by professionals in fields such as engineering, architecture, video editing, and 3D rendering. Advantages. Enhanced performance for demanding tasks, often with support for multiple monitors and specialized hardware. 3. Servers. Purpose. Computers that provide data, resources, and services to other computers over a network. Components. High-performance CPUs, large amounts of RAM, multiple storage drives, and redundant power supplies. Usage. Hosting websites, managing network resources, running enterprise applications, and storing data. Advantages. Designed for reliability, scalability, and continuous operation, often housed in data centers. 4. Mainframes. Purpose. Large, powerful systems used for large-scale computing tasks. Components. Multiple CPUs, vast amounts of RAM and storage, and advanced input-output capabilities. Usage. Used by large organizations for critical applications, such as transaction processing, large-scale database management, and enterprise resource planning. Advantages. Exceptional reliability, security, and the ability to handle massive amounts of data and simultaneous transactions. 5. Supercomputers. Purpose. The most powerful computers used for complex simulations and calculations. Components. Thousands of interconnected processors working in parallel. Usage. Scientific research, weather forecasting, quantum mechanics, and molecular modeling. Advantages. Unmatched processing power, capable of performing billions of calculations per second. 6. Tablets. Purpose. Portable touchscreen computers. Components. Touchscreen display, battery, and typically a virtual keyboard. Usage. Ideal for browsing the internet, consuming media, reading ebooks, and light productivity tasks. Advantages. Highly portable, user-friendly, and versatile for casual use. 7. Smartphones. Purpose. Compact portable devices combining a phone and computer. Components. Touchscreen, processor, memory, storage, and various sensors. Usage. Communication, internet browsing, social media, photography, navigation, and running a variety of apps. Advantages. Extreme portability, multifunctionality, and connectivity. 8. Embedded systems purpose. Specialized computing systems embedded within larger devices. Components, microcontrollers or microprocessors integrated with specific software. Usage. Found in everyday appliances like microwaves, cars, medical devices, and industrial machines. Advantages. Designed for specific tasks, providing reliability and efficiency within their applications. Each type of computer is tailored to specific needs and environments, offering various advantages to cater to a broad range of tasks, from everyday personal use to specialized professional applications. Unboxing and setting up a laptop computer. This course is designed for absolute beginners. If you have never turned on or used a computer before, this step-by-step guide will help you set up a brand new computer and start using it with ease. Prepare the area. Ensure you have a clean, flat surface to unbox and set up your computer. This will help prevent any components from getting lost or damaged. Open the box. Carefully open the box using a pair of scissors. Be cautious not to damage the contents inside. Remove components. Take out each component one by one. Typically, you will find the following items: the laptop, power cables, instruction manuals, and warranty cards. Check for damage. Inspect all components for any visible damage that may have occurred during shipping. Setting up a laptop. Take the laptop out of its packaging, removing any protective films or covers. Connect the laptop's power adapter to the laptop and then plug it into an electrical outlet. Although many laptops come with a partially charged battery, it's good to start with a fully charged one. Lift the lid to open the laptop and access the keyboard and screen. Power on. Press the power button, usually located above the keyboard or on the side of the laptop. Initial software setup. Operating system setup. Follow the on-screen prompts to select your language, region, and keyboard layout. Connect to a Wi-Fi network if you're using a wireless connection. Sign in with your Microsoft account for Windows or Apple ID for macOS if prompted. Set up a user account and password. Congratulations, and what's next? You did it! Once you see the main desktop screen, your computer is officially set up and ready to use. You've successfully taken it from the box to a fully operational state. This is the perfect handoff point to Module 2. Now that the foundational setup is complete, we will explore how to make this computer truly yours. In the next module, we will cover installing essential applications like a web browser, office software, and security tools, customizing your settings to change the wallpaper, adjust display options, and organize your workspace, and finally, navigating the file system and understanding how to save, organize, and find your documents.